Hi, everyone. So my name is Patrick Bolañez. I am a PhD student in computational neuroscience at Boston University and a research associate in the program for neuroscience at Bowdoin College. I'm super excited to be speaking to you all today asynchronously about GGPlot2, as well as a little bit about the principles of data visualization. Um, Again, I apologize that I am not offering this synchronously today, but as I mentioned in my email, I will be able to provide a lot of support to folks outside of this session. So if you would like to join the Slack where we have a whole bunch of users, you're able to sort of lean on them as a learning group, just send me an email or a DM on Twitter, and I'm happy to add you to that. Also, as I mentioned, I'll be offering some live office hours over the course of the next month. So as you're sort of going through this content, if you have any questions or run into any issues, definitely feel free to come to one of those sessions. And I'm happy to work with you to get through that. So as I mentioned, we're working with ggplot2 today, which is a very popular package in our programming language. And we use that for data visualization. So today we're going to talk a little bit about the basics of data visualization, not a whole lot, but then we're going to get into understanding the basics of the grammar of ggplot. So how do we even think about generating a plot or reading the code associated with it? As such, we're also going to need to install it. So we're going to show you how to install the package and run it. We'll take a short break in between, and then so sort of we'll build up a couple of examples of popular plots. So our traditional scatter plots and things along those lines. And then from there, we'll close out with a sort of case study or a couple of case studies that I'm going to give to you. I'll sort of give you some hints on how to start with them. But you're going to sort of generate two plots from nearly from scratch to sort of practice your new skills. And if you're able to complete those, you can send those to me via email. I'll go through and give you feedback, and then I'll send you sort of a certificate for you to, sort of document that you came to this workshop or things along those lines. So if that's helpful for your CV or applications or things along those lines, especially the younger folks, I'm definitely happy to do that. Great. So we can go ahead and hop right into it. The best place to start is obviously through, just defining what data visualization actually is. I'll put this quick disclaimer here that I am not a data visualization expert. It's not my area of research. I'm more of a computational statistician in neuroscience. So I work intimately with data visualization every day. But it's not sort of my area of expertise. And in fact, some folks in this group might be more experts than I am. So if you, again, would like to lean on that learning group in Slack and you have questions, definitely come in and ask. And I'm sure someone will be around as well as myself to sort of answer any questions. But my understanding of data visualization is just that it is the simple visualization of our data. And so with that, we have to keep a bunch of different things in mind, right? So if we go through all the work of our experimentation or general study design, we collect our data. We then need to sort of abstract it in certain ways, pick out certain features of it, to then do our analyses and try to communicate some key insights. And so, obviously, when it comes to data, we're going to need to focus in on our proper data collection techniques. We need to organize the data for a specific purpose, but that's not the whole story of how we create good data visualizations. In other words, the plots that we generate from our data directly do not necessarily fall logically out of our data. So we have to think about two other things, specifically function and design. And so design is essentially figuring out how can we create or show our data in an impactful way that sort of balances this idea of striking visuals, but also accuracy, going back to the data, and the function of the data. So what I'll talk about in just a second. And I want to pause on this idea of design and then come back to it in just a second, because I think that's typically where people will run into trouble. So people will focus so much on this idea of storytelling and creating striking designs that they will sort of misrepresent their data in a way that's counterproductive, or present their data in a way that is, strikingly beautiful and an expert might be able to decipher relatively easily, but it's not necessarily something that the average consumer who might have their area of expertise in another area, it's not something that those folks can sort of digest without a lot of time and attention. So we don't just want to grab people's attention, we want to grab their attention in an effective way where they can sort of draw some insights from the visualization. Function is something that I'm primarily concerned about, and it's sort of thinking about how do we sort of communicate our data in an accurate and simple way, but coupled with design, it's going to be an attractive way to represent our data. And so we want to have sufficient complexity. So we don't want to sort of undersell our data or our insights, but we do sort of want to, communicate them accurately in a way that doesn't take a large amount of attention or time to get the point across. And so the main theme going throughout this to keep in mind is this idea that data visualization is about visually depicting key insights from the data, and doing so in a way that's accurate, doesn't take a lot of attention, but also is striking. So we're able to sort of draw people in and have those people be curious about our questions. And as I mentioned, some people will go overboard on the actual either design, so the actual appearance of the chart, or they will sort of show their data in a way that's overcomplicated, where it might be interesting and we might see certain patterns, but it might not be clear what those patterns actually mean. And so on the left here, this might be an example where maybe there's a lot going on. It's a very beautiful chart, and someone who's very familiar with this particular field might be able to look at this quickly and see, oh, this is what's going on. But for example, we see all these little tiny tick marks here. We see labels that are perhaps a little too small. We see multiple different color scales that might imply different things about the data. And then we sort of have a full circle where people have to orient themselves in multiple directions to try to understand what exactly is going on. And so this plot will definitely serve a purpose in particular contexts, but perhaps in many more contexts, it will not be the most productive way to show this data. On the right, we have sort of a common plot from specific network analyses. So this might be something from like a social network analysis or digital text analysis, where we're sort of looking at how words are related to each other. And in some ways, this is a good plot. So how I've used this in the past is to look at sort of the clustering of colors, and we can see there are certain impactful nodes, for example, and we see that, the yellow color here is opposite of blue. And so if you're familiar with whatever data set this came from, that might be a meaningful sort of visualization for you. But for the average person, this is probably going to be a little off-putting or a little confusing. And so it's good that this wouldn't be sort of the leading figure, so to speak, just because it requires a lot of attention and a lot of sort of abstract thinking to be able to take away a good understanding of what's going on here. And so while this might be helpful to certain practitioners, we might want to think of either choosing a different figure or sort of supplementing it with something else that can communicate the point. And so sometimes, as I mentioned, sort of really simple or foundational approaches can be the most powerful. And so here we don't have anything terribly complicated going on. You'll probably see in a lot of ways these figures will typically be represented in papers. So we have our classic heat map over here, for example, to show sort of the potency of a particular feature, or sort of a trend of up versus down, or positive versus negative, et cetera. In the center, we have something that we'll typically see where we have two different data points paired up, and we might have, an increasing trend line be represented by green, and a decreasing trend line represented in red. We'll touch on a little bit later why green and red probably aren't the best colors, specifically for those who are colorblind, but that sort of ties into this idea of powerful data visualization and accessible design, which should go together necessarily, but often do not. Then we have, really simple plots. One that I quickly generated here, it's a cumulative distribution function of earthquake data from California. This is an example where we might want to sort of do a little bit more work to make it less boring. So we might want a little bit more creative design. But for understanding whether or not for example, a normal distribution or Poisson distribution is a good fit for our data, this gets the job done. It tells us exactly what we need to know. So in this case, Poisson distribution would not be a good fit for the data. And then we also have our classic, clustering techniques here, where we might differentiate certain points with different colors and then circle them. So these are all, simple ways to communicate data. Some are more attractive than others, but definitely gets the point across. So we're going to try to go for that. And I'll also quickly mention that lying with data is pretty common, but I do want to focus in on sort of unintentional misrepresentations of data. We've all sort of heard of the spurious correlations, where two things that are completely unrelated end up being highly correlated. So I just picked a silly example here where divorce rate in the state of Maine, which is where I went to my undergrad, is highly associated with per capita consumption of margarine, right? And this is a beautiful plot in the sense that it shows a really clear trend line over time. It shows the connection of divorce rate in Maine on the left, and then the margarine consumed on the right. But obviously, this is something that is highly misrepresenting the context in the sense that these two things are completely unrelated. And so this is just a silly example because I didn't want to show anything that would critique someone's work heavily. But the power of data visualization is we can sort of group these things on the left and the right and present them as if they're similar. But in reality, these two y-axes are not comparable at all. And so this is a way to sort of misrepresent data by just making our data visualizations forcing them into a particular narrative that we're trying to present. And so to sort of avoid this idea of misrepresenting data unintentionally, I did want to take a couple more minutes to talk about some do no harm principles from this guide here from two lovely researchers. And really, it's just about thinking about how do we apply equity awareness in data visualization to try to minimize harm as much as possible. Our data had to come from somewhere. For many of us, our data comes from people. In my discipline, it primarily comes from animals. So we want to be respectful of those animals. So we want to sort of contextualize those independent points and make sure that we're presenting and talking about our data in a respectful way. And so, one theme is just to simply put people first. And so we have this quote from Harris down here in 2015. So if your data is about people, make it extremely clear who they are or were. And so I'll sort of extend this a little bit further also to apply to animals, right? So we want to be aware that, oftentimes if we're doing animal research, they're going to sort of be killed or something along those lines for the sake of the research. And so we want to sort of communicate that in a respectful way, and we want to not be wasteful of our animals. Same thing with people, right? So these people are oftentimes still walking around. And so even if they're unidentifiable, sort of the way that we show data and the way that we talk about our results from data can often be harmful to particular groups. And so we want to sort of give both the near and the far view. So we're still able to abstract the data and talk about it in certain ways. So if we're in sociology or something along those lines, we can talk about our broader trends. But then it's helpful to sort of put things back in context, either in our literature review or through the way that we're setting up our data visualization to make sure that we're being respectful. Theme number 2 is essentially to sort of use personal connections to help readers and users better connect with the material. And so this is sort of following off of the last point, but we want to make sure that we're not sort of alienating our data so much that people don't understand sort of the implications of that work. And so in some fields, this might be more important than others. But I really want to emphasize this idea that providing context is not an emotional appeal, and it's not biased research in any means. It's just allowing us to sort of understand the real world implication of the work that we're doing. And so, for example, a couple of years ago, I was working with someone who was a dementia researcher, but he had never met someone who had dementia. And so that's a pretty weird concept to me. But it's important to sort of be aware of what you're doing and understanding that the way we present our data does oftentimes have impact on the way people think about themselves and how they relate to others. Theme number 3 is to sort of use a mix of quantitative and qualitative approaches to tell a story. And so I just picked a random example for my own field here. But if we think about independent components in electroencephalography, so when we're recording from the scalp of the brain, we often get these time series data, the little squiggly waves, and that has a lot of information for the research that I do. But it's also important to sort of understand where those independent components are coming from. And so there's a lot of different complicated techniques, right, to figure out where a given dipole in the brain is coming from. But it's helpful to sort of show people visually where exactly a particular feature that you're measuring or analyzing is coming from. And so quantitatively, we might think of time series data, and to some degree these heat map based scalp projections are also quantitative, just because algorithms are generating them, but it's also qualitative in the sense that it tells a more qualitative story. So we're not talking about things in terms of values, but rather general trends based off of a different, a specific color map. And so, the real point here is to recognize in your own field when qualitative data is enough, and to sort of avoid this idea of qualitative data being settling or non-rigorous. So oftentimes the qualitative data is more appreciated or is more helpful than quantitative data. And so in some cases, it's even more informative. And so there's no reason to sort of overcomplicate something that doesn't need to be overcomplicated. Theme 4 is sort of this idea of creating a platform for engagement. And so if we're thinking about really complicated ideas and you want to sort of communicate it in the best way, the currency for many of us is through academic papers or through briefs or something along those lines. But there's also a lot of different ways that we can communicate things. And so in the education sphere, for example, you might want to create like an interactive data platform to make something more lively. And so for example, I used to be a teaching assistant, and we were trying to communicate this idea of Morris-Lacar neuron models that sort of follow the shown equations here. They seem very abstract, they're relatively confusing, and the point of the class was to sort of help people understand the dynamics under that. But what we decided to do is sort of create, an interactive simulator where we're able to allow people to engage with the actual equations, engage with the data that's created from the environment. So it's sort of produced in a really visual, highly interactive way. So they can sort of click on specific points to understand what the different coordinates are and what that means biologically. They can change different parameters and things along those lines to see how it impacts the system. And so we can do this in all sorts of areas, such as natural language processing. You can show your geographical data through GIS software or something along those lines. So even though many of us will communicate in papers, it's important to make our data lively and accessible. So consider making it interactive in some sort of platform. Theme 5 sort of harps on some of the earlier themes where we really should be considering how you're framing an issue and how that frame that you choose can sort of create a biased emotional response. And so on the right here, I just have a tweet from a couple years ago where it's sort of showing the size of people, specifically female identifying individuals, and how their height sort of is associated with their particular lived country or place of origin. And so, for example, folks from India here are placed in a very unflattering light of, being shown as like a very small sort of icon of a gendered individual. And in fact, they're much, much smaller than someone who's just, 2 inches to the left here from South Africa. They're shown completely different, even though the actual, overall change in height is relatively small. And so this is not only misrepresenting the data, i.e. Sort of you're violating the area principle where each of these individuals looks like they're taking up exponentially more space with sort of minor differences in the actual y-axis. But also, it has real world effects in terms of how people feel. So the questions to sort of ask here, are you playing into us versus them dynamics? So leaving folks out, and are you creating needless complexity, in a situation which also can be sort of read as leaving people out. So in most cases, understanding how we're representing people is going to be important. Finally, theme 6 is to sort of recognize the needs of your audience. And so the sort of trivial version of this is what is the knowledge level or educational background of your audience. And so, if you're talking to a room full of PhDs in your specific subdiscipline, you're going to speak differently than if you're talking to someone who has not graduated from high school or something along those lines. Both people, are highly intelligent and have their own skills, but it's important to sort of understand someone's background so you don't sort of take things for granted, which will then leave room for ambiguity and miscommunication. Now, the non-trivial version of this, which is very relevant today, is what is the amount of attention someone requires to get your message? In other words, don't do too much. And so if someone who is an expert in your field has to take an extraordinary amount of time just to understand your data because you decided to present it in a particular way, which is notoriously a problem in my discipline, you should consider doing less and sort of breaking up a figure so you don't have 3 axes when you could just have 3 separate plots. And in some cases, it's necessary to do something like that. So if a journal, for example, has a figure, a cap or something along those lines, I definitely understand that. I relate to that. But when you have the luxury of not having a cap on the number of figures, not having a cap on the number of color figures or things along those lines, you should really try to take advantage of that and communicate things very accessibly. So, in the end, it really is just keeping these people-centered questions in mind. So, how are these data generated? Are these data demographically representative? Who is included and who is excluded from these data? Whose voices, lives, and experiences are missing? How much can this data be disaggregated by race, gender, ethnicity, et cetera? Why were these data collected? Who stands to benefit from these data? who might be harmed by the collection or publication of these data. And so if we sort of keep these in mind and sort of take a people-centered or animal-centered approach to our work, we should be fine. And then if we sort of respect our data and then also respect our audience, we'll be even better than fine. We'll be in a very strong place to communicate. Finally, a note about accessible design. I'm not going to go into this heavily here, but it is very important to sort of think about, the way that we are communicating our data or our figures. And so really consider looking up some resources or taking a workshop or something along those lines about, tagging figures so people who are not engaging with them in the way that you're assuming are able to partake in the information, using accessible color scales or textures. So, making it textured or making it colors that people who are, colorblind can see. Using accessible language is something that's really important. We mentioned earlier, but showing data in multiple formats to make it, highly understandable. All these sorts of things are best practices. So really consider how you can go about doing so. I now want to take a couple of minutes to talk about this idea of sort of knowing your funnel, right? So what I mean by funnel here is just like when we're communicating a particular narrative, we need to sort of be aware of the progression of where we are in the process to actually generate a successful interpretation of our data and try to represent it in a data visualization. And so, up first with this idea of, data quality criteria, we want to sort of develop our protocol and understand what success looks like. Some really basic notes here is not everything needs to be phrased into a yes or no question. And so, not everything subsequently needs to be a hypothesis test. So if we're sort of keeping in mind what we're trying to say at the end, it allows us to sort of collect our data in a way that is most helpful for the question we're trying to answer. And so oftentimes people, without even thinking about it, will collect all this data. They'll be binned in a certain way or something like that. And then they're sort of forced to ask yes or no questions. But really what they're interested in is looking at, the general spread or character of the data in a more qualitative, way or in alternative quantitative ways. But they're sort of stuck with doing hypothesis tests. And so when we, visualize this data, typically will be something like a cluster or a particular type of bar chart. In a lot of ways, those are powerful and they're great data visualizations, but they're not always the best. So, keeping in mind your protocol and defining what success looks like, even if you don't know what the answer is going to be great. And you can do this by sort of being explicit. So if you don't understand what the protocol is, someone who's reading your work later on is definitely not going to understand. So, if you are sort of taking all this time and energy to sort of run a given experiment, you want to sort of make sure that we're, answering the questions that we're actually interested in by the way that we collect our data. In actually collecting the data, though, we want to make sure that we're sharing the timeline in our subsequent publication. So, oftentimes people will jump around to present what the best narrative is when they're actually doing their experiments. And so in biology papers, this is notorious where people will present a logical flow that makes the most sense after the fact, but it actually won't be the order in which they did the experiments. And so in some cases, it's easier to read the former, but it's better in terms of communicating things to do the latter, where we're sort of being honest about what experiment motivated what other experiment, how different data points are relating to each other in our understanding of the system, and things along those lines. And so, sometimes you can generate, figures to sort of show a logical flow chart of your experiments, and that will be, helpful for a lot of people. Even if you choose to present your data or your figures in the most logical way, you're also able to, in supplementary material, sort of show the actual relationship between experiments. So I would highly recommend that. In terms of our analysis, again, we've touched on this, so I don't want to harp on it a bunch, but qualitative versus statistical, descriptive statistics are still statistics, and so we want to avoid doing too much unnecessarily. And so, I'm going to harp on this again, but hypothesis tests don't imply rigor. Oftentimes, they're probably the most trivial, probabilistic tests you can do. And so, if you don't have to do a hypothesis test, i.e. your question is being better answered in other ways, don't do it just because you think you have to. Also on this front, really try to motivate why you did the analysis from your original scope. And that's going to sort of make our figures, but also our papers much better. Quantifying uncertainty is a big one in figures. So my real plug for this is, if you don't know how to quantify your uncertainty, ask a sort of statistics-focused colleague, and offer them co-authorship or consulting compensation if it takes a high amount of time. But the most traditional way is through confidence intervals, which many people do, but oftentimes people will not pick the most productive type of confidence interval to communicate their uncertainty about a particular projection, or they're interpreting them incorrectly. And so we want to make sure we're picking the best form for our figures to make sure that we're sort of communicating that information in a rigorous way. And then finally, our interpretation, right? So this is distinct from quantifying our uncertainty, i.e. our statistics and things along those lines. Your interpretation should be an argument. And so oftentimes this will take place in writing, but for a lot of people who aren't in academia, or even in people who are in academia but will present in accessible formats such as conferences or something along those lines, we want to make sure that our figures themselves are, making a particular argument. So we're highlighting the features that we're interested in to sort of draw people's attention to those features of the data. And so really this idea of interpretation comes down to abstraction. What is the feature that we want to pick out? What is the point that we want to make? And we want to sort of minimize other features of the data to highlight those specific areas. And so, best practice, right, will highlight different features in different figures so we can get the full story. But we don't want to sort of highlight everything in one figure, because that's how we get lost. Great. So now we can go ahead and move over into R. We'll move back into this PowerPoint in just a few minutes, but I want to get going and install ggplot and then get it running. So I'll see you over there. Hi, everyone. So we've moved over to our studio here, and I'm going to show you the two major ways to install a package in R. And the package, of course, that we're going to be installing is GGPlot2, but this will hold true for most mainstream packages in R. If you're interested in other installation techniques, let me know and I can direct you appropriately to figure out how to install things from GitHub directly, or things along those lines. But when it comes to ggplot2, the two main ways to install it are through the console and through this little packages tab here. And so I introduced packages in our asynchronous videos on the website, but I do want to sort of communicate that packages are really just bits of code that are built on top of the baseline computer language called R to perform particular tasks more easily. And so some packages are really simple, where it might have one or two functions sort of built into it. Those are packages that I tend to develop just because they help me in a particular way. But others are sort of entire universes of functions and data and things along those lines that allow us to do all sorts of different things. So one popular example is tidyverse, which is a package that allows us to do all sorts of complex data wrangling more easily in R. But the one we're dealing with today is ggplot2, which is sort of its own universe of data visualization. So all sorts of things will be installed in it, such as practice data sets, all sorts of functions and things along those lines. So it's a really good one to have. So there's two main ways to install, as I mentioned. One is through the console, which is right down here in the bottom left of the screen. If you're unfamiliar with sort of the organization of our studio, feel free to watch that asynchronous video again. But we can sort of write the code install dot packages. We're going to open parenthesis, put two quotes. And then inside of those quotes in parentheses, we're going to write the word GGPlot2 in all lowercase. So what you're going to do after that is go ahead and hit enter. I am not going to do that just because I already have it installed, as you can see here. But if you do that, you're going to see all sorts of code pop up in your console. And you can just sort of go ahead and ignore that until the end. If you're on a baseline theme, or the generic theme in R, it's going to appear as red text, and your background will be white. So it might seem a little alarming, like something's going wrong. But in fact, that's just the default color scheme. So no concerns there. Once you've gone ahead and installed that, though, you're going to run this command, library, parenthesis, ggplot2. And when you do that, you're not going to get any output. It's just going to load successfully. But once you've done that, you're able to sort of use all the functionality of the package. And so as I've written here, you only ever need to install ggplot2 once, but you will need to load the library every time you choose to use it. So every time after the first time, you just need to run this one line. Now, the second way to install a package is by doing it through the Packages tab, as I mentioned. And so you'll see that there's a nice little install button here, and that makes it really easy. So you can go ahead and click the install button. I'll move this out to the side, and you can just search the name of the package. And so in our case, it'll be ggplot2. And you can just click that. Go ahead, install the dependencies. Do not change the install library here unless you know what you're doing. And then go ahead and hit the install button. Again, for me, it's going to pop up with a message that says I already have it downloaded. But for you, you can go ahead and install it that way if you would like. In terms of loading the package, it's pretty much the same thing. So there's also an alternative where you can scroll all the way down, find the ggplot2 package, and then you can just check the little box here. So what I just did is unloaded it, and then if I want to check it again, it'll run the code for us and then load it properly. So you can either do it in the GUI, i.e. this little drop-down menu over here, or you can do it directly in console. Great, so let's go ahead and jump into our code now. Great, so we've hopped back over to our PowerPoint for just a second. As I mentioned, we will be going through sort of the foundational background for ggplot2 in actual code in just a second. But I did want to point out some resources that I'm going to put on the website linked in the description of this video for sort of engaging with ggplot further. So where I'm going to be working out of is an entire textbook that was written on this. So I tell you this in for two reasons. One, I'm going to link the textbook, the open access version of the textbook below. So you're able to sort of work through some chapters on your own that are going to be really helpful in your own development. I'm just going through some real basics here. So that's number one. But number two, in terms of what you should expect at the end of this session versus what you should expect in your first couple of months versus your first couple of years with working with ggplot2 are very different. So ggplot2 is complicated enough where multiple textbooks have been written on it. This is just one of them that I really enjoy. So I just want you to know that you shouldn't feel overwhelmed if you are not able to understand how to engage with every feature of ggplot. Some plots are just going to give you trouble. But I just want you to know that there's a lot of resources out there. And so hopefully this workshop will give you a working basic language to move forward and ask the right questions. I am going to also link this website here called the 50 Top ggplot2 Visualizations. What's really great about this resource is it actually provides sample code for how to generate the particular plot. And so this is a great way to sort of see an example and adapt that for your own code. So one thing that's really a misconception, and also a little contrary to many of our nature, especially in academia, when people start coding, is that you typically don't write your code from scratch. And so what that means is oftentimes people will learn by looking up other people's work, building off of that work, and sort of making it better or making it relevant to their own problem that they're trying to solve. And so, learning a computer programming language, so R, Python, Java, et cetera, really isn't about sort of being fluent irrespective of a problem and then just knowing how to sort of speak in this language. Rather, it's sort of learning how to use the language through specific problems. And then over time, you accumulate enough knowledge where you can sort of see how things connect. And then you can start writing things from scratch more easily. But typically just sort of learning something to learn it before having to solve a problem or use it in your own work is not particularly helpful. Interestingly enough, right, incentives in business tend to be the opposite of that. And so we want people to have, all of the skills before they come in, which is not helpful for either side. So, just, a plug here, go through this if you want to figure out how to generate specific plots. It's a great place to start. And then you can kind of use it to build your own code. One thing I'm not going to be covering in this workshop is this idea of data wrangling. So, we're doing data visualization after our data is formatted in a way where it's easy to use. So we're only going to be using pre-wrangled data. So in the future, I'm going to offer a workshop on data wrangling. It's very frustrating. It's very time consuming. It's very difficult. And there's a lot of really interesting questions relating to data wrangling, like what do you do with missing data and things along those lines. But for today, we're just going to be working with clean data. So, sometimes if you're going to go home and jump right into using GGPlot2 with your own data, you need to understand what format the data need to be in to successfully generate the plot. But I personally think that it's helpful to work backwards from the data visualization to understand how to get your data in a particular form. Because if you don't understand GGPlot2, you're not going to understand how to wrangle your data or what format it needs to be in. So real quick, I sort of alluded to this, but my opinion on how to learn R and GGPlot2 is sort of this dichotomy of top-down versus bottom-up approaches. So bottom-up approach here is where you're sort of learning all the fundamental skills of a particular language right off the bat, irrespective of a particular goal or task. Whereas top-down is sort of learning through a particular project or a focus on a problem and really only learning what you need at the start. I think for people who are just learning a language or learning a package or a given universe, et cetera, the top-down approach is the best. You can sort of see examples, you understand when and why it's used, and then you can use those examples, update them to solve your own problems. That gets you pretty far for a long time in any language you're trying to engage with. When you get to a certain point, though, it's important to switch to bottom up. And that's because if you're trying to create your own package or you're writing unit tests or something for a package that you're trying to push out or something along those lines, it's important to understand the fundamentals of the language in terms of how do you make something more efficient, how do you draw on parallel processing or something along those lines. So, understanding the whole picture eventually is going to be the goal. But from the start, sort of top down is a good place to begin. Great. I'll put this here. So in terms of the extra reading in the textbook, I identified a couple of good chapters to read. So, how do you annotate your plots? Position scales and axes. We're going to deal with a little bit of that here, but there's an entire chapter on how to show different axes at different scales and things along those lines. We're going to be talking about, or we're not going to be talking about color scales a whole bunch. So, that's something that's essential to learn. So I recommend that chapter. We're going to go over the foundation of the grammar in GGPlot2, but mastering the grammar is something that's essential to be able to sort of generate a plot without thinking about it. And then also chapter 14 is a good review of something we're going to be talking about, but it's this idea of building the plot layer by layer. And so that's a little counterintuitive to folks who, might have a drag and drop or a click down menu to generate a particular plot. You just sort of put all the options in, click one button and generates the plot. In GGPlot2, it's different in the sense that we actually have to understand the actual space that we're generating with the plot and then kind of go from there. So we'll be coming back to this case study in just a minute, but let's hop back over to R, and we're actually going to get into all of our code now. So you should have that to look forward to. See you in a second. Awesome. So we have moved back over into our studio, and I'm going to be taking you through this notebook here, which is called GGPlot2 Notebook. But I'll be making this available for everyone to sort of download and run on your own to practice. That will also be helpful just because there are a few questions sort of embedded throughout this that I will not be answering here. So for your own practice, I highly encourage that you download this and then kind of practice from there. But so right off the bat, we have a new sort of play data set here. So when we go ahead and load GGPlot2 by running library and then putting GGPlot2 in it, we get a whole bunch of sort of things downloaded with it, all the functions, but also quite a few data sets that are already data wrangled for us. So they're all set for us to practice with. So we have access to this MPG data set, which is sort of engaging with this idea of vehicles getting a certain amount of gas mileage, having certain features to the car and things along those lines. So to sort of orient ourselves, let's go ahead and run a common command called str, which stands for structure, and we can see the structure of our MPG data set. And so a couple things to dissect here. If you're new to R, we see that this is a tibble. So a tibble is essentially a modern day data frame. So it's related to data frames from the past. So you can think of it in the exact same way as we used to, where a data frame is merely a table. So if you think about this in terms of Excel, right, this is just an Excel spreadsheet. Tibble just has a lot of better features than a data frame. I'm not going to be going into those intricacies here, but you can sort of think about this as, having 234 rows and 11 columns. So think of this as just one big spreadsheet. In terms of the actual column names, right, we see a $sign here, which is common in R. So that is an indicator to sort of say, well, within a data set, I want to access a particular column name. So we have things like the manufacturer, the model, year, things along those lines, all the way down to class. And so some of these are characters, which is CHR. Some of these are numerical values, which are abbreviated NUM. Some of these are integers and so forth. Now, just a note that came up in my last workshop. So some things are called numbers, some things are called integers, right? And some things are called float variables. So what's the difference between a numerical data value and a float or something along those lines, right? Well, there is no difference. So if you sort of look at the difference between a numerical and a float, they're just numbers that have a decimal point. And why there's a distinction is a historical reason, not a functional reason in R. Something that you should know, though, is that numerical in a float have a decimal, whereas the integer is a number without a decimal. And that's always the case. In some languages, that's a concern that you need to know about. So how do we sort of go back and forth between the two? But most modern day languages, and it's the case in R, you do not have to worry about that. Most functions will automatically switch between integer and numerical when we need to. Great. So as I mentioned, table is just a modern data frame. And there's three main things that I want to sort of point out in this data set for the following question. But we have the variable CTY and HWY, which is, and I'll just go ahead and make that code. So STY and HWY essentially are the miles per gallon for the city and highway driving. For some folks, miles per gallon might be an unfamiliar metric, and we'll get to that actually in a second. But it's essentially just like how far you can go for a given gallon of gas in your car. So the DRV, the next variable, is the drivetrain. And so it's essentially saying, well, you know, is your car front wheel drive, rear wheel drive, or four wheel drive? So where is the power in the car coming from? So if it's four wheels, all four of them are being driven by the engine. If it's front wheel, the engine's only sort of driving the front two wheels, whereas the back two are just sort of spinning as you move along. And then DISPL is standing for the engine displacement, which is essentially a proxy for engine size. So the reason I'm taking time to go over those variables, right, and sort of get an idea of this data structure is, number one, we're going to be working with this data set going forward, but also I added this little question here from the textbook to sort of help you think about the basics of data wrangling or manipulating your data in a way to eventually generate some sort of analysis from your data that you weren't already planning on, or you don't already have, available to do right away. And so this question is simple. It's just saying, apart from the US, most countries use fuel consumption, which is essentially fuel consumed over a given distance rather than fuel economy, which is what I just described. So, how can you convert the CTY and HWY variables into the European standard of sort of the liters per 100 kilograms or kilograms, kilometers, kilometers, and then add this as a new column to the data set. Really struggled with kilometers there for a second. So the steps to solve the problem here are sort of outlined here. But I want you to sort of think about doing it just to pick up some important skills. So number one, you're going to need to do a real simple pencil and paper dimensional analysis or unit conversion. So you're going to be starting with miles per gallon, and we want to sort of end with liters per 100 kilometers. We're then going to take that value and we're going to sort of put it into our data set through a couple of different steps. So first, we need to sort of save the MPG data set as a new variable. And this is sort of a way of sort of cloning our data. So we're not altering this original data set. We're just going to make a copy and save it in an object. If you're unfamiliar with variable assignment, go and see that asynchronous video on the website. But so we're going to go ahead and run this. And now we see that in dataset, we have the exact same dataset as before. So our tibble, where we have the manufacturer, model, displacement, et cetera. Great. You'll also see here that you're able to sort of click through it in a nice way. So we have all these different pages, so to speak. You can scroll through the columns like this, just with the little arrows. But so that's the basic thing. You're then going to need to convert your pencil and paper unit conversion to code. So you're going to need to set up that actual conversion. So I encourage you to look up, how do you go about doing this? The basic asynchronous video that I showed you in terms of the mathematical operators should be sufficient for you to be able to do that. But then you're going to need to add the code as a new column. So you're going to add it on to the end to the right of the class here. And so there's a couple different ways that you can do this, but I really encourage you to sort of look this up just by Googling things. And this is my way of encouraging you to be okay with going onto the internet and saying, how do I do X, Y, Z? So if you didn't have any questions to sort of Google before to get started, this is sort of your cue that the best programmers Google things before they sort of memorize it. Now, getting into the nitty gritty of GGPlot2, which obviously is what we're all here for, every ggplot essentially has 3 key components. And so we're going to be using this data set up here to sort of get an intuition of these components. But the 3 components are essentially data, aesthetic mappings, and then the geom function, which is essentially short for geometric. In terms of where are these terms coming from? Well, they come directly from graph theory, which I actually very much appreciate. So it's very much a sort of bottom-up approach to how do we build up a plot where we're going to have actual data that we're going to feed into the plot. But then we're going to say, well, how is our data going to map on to a given coordinate space? So whether that's Cartesian space or something along those lines, it's going to map on in a particular way. So it's going to tell the program how to organize it. And then once we have sort of those visual properties of how the data is going to relate to space, we can add the geometric function or geom, which is essentially just going to be an actual layer on the space. And it's going to tell the program how we're going to sort of render each observation. And so the main thing to take away here is that when we sort of call up ggplot, so ggplot2 is the package, ggplot is the basic quick plotting function in the package, we can always figure out where the sort of 3 components are. So data, right, is going to be the first input. And so how do I know that? Well, MGP or MPG is the data set that we just went through. And so we see that it's going to be in the first position. But recall that the data set itself is called MPG. So we're not just feeding it particular variables, we're feeding it all of this information. So ggplot, when we add this first argument, MPG, it's getting everything. So it's getting all columns, all rows, unless we specify otherwise. So the aesthetic feature or the AES is what's going to be saying or telling ggplot2 what variables from this data we're thinking about or we're trying to do something with. And so, old school folks might be familiar with piping. So we sort of start with a data set, we subset it through a pipe, and then we can sort of move from there. So we can sort of analyze that subsetted data. But once we've done that, right, we need to tell ggplot how to render. So all we have here is the total data set. The aesthetic, we're going to assign X to be displacement, Y to be the highway mileage, and then we're going to add a plus. I'll explain why we're doing this. And then sort of have this argument down here called geom point. And so let's go ahead and run this just to start getting an intuition of what's going on here. Excuse me. So with our ggplot, we already have a basic scatter plot here. So many things have just occurred that we were expecting. So number 1, X, our displacement, is going to be on the X-axis. So we saw earlier when we were going through the data set, this is the range of displacement. So that makes sense. Now with Y equals highway, it's the same thing. It's going to be on the Y-axis. And then we get our basic scatter plot. Now, what maybe was less intuitive is this plus going on down here. And so what's important to note is that you can add multiple layers onto the basic sort of XY plotting or whatever aesthetic you feed to it. And we're going to be seeing some examples very soon. But so there's a whole bunch of these different geomes. And basically, they tell us what form we want the data to take in a particular layer. And so once we have our X and Y, if we wanted our point, you just build off of the original data set and specific subsetted variables. And then we tell ggplot that we want it to be in a scatter plot form by calling geom point. So the plus is going to add to our basic data and subsetted data. It's going to tell us how we want that data to be rendered. So I want you to sort of go through more complicated options. So with exercise 2, we just went through sort of what is calling, or where the data is, where our aesthetic mappings are, where the geom function. So geom function, this is our aesthetic, where those two variables are X and Y, and this is our data. But I want you to sort of get in the habit of being able to read code. So when you see something online, where each part of the line is coming from. So this top box here, we don't need to worry about, but I am going to run it. It's just going to get our code in our data rather in a particular format. But then let's go ahead and run this one. So quite a bit more complicated here, but it's sort of the same form, so we can go through and figure it out. So if we want to find data first, where should I look? Well, let's come up here. We have our ggplot function, so that's our basic function as we mentioned. We have this thing called mtcars in the first position here, and it turns out that that is actually the data set. So where is our data coming from? Well, we have mtcars. So if I want to do that, mtcars is the data set. Great. So if we scroll up here, right, we're looking at the aesthetic, so the aesthetic mappings. So we can go ahead and find the AES argument, and we see something different going on here. So we have our X, we have our Y, and then we have our label. So let's see if we can try to figure out what's going on here. So for X, right, we have the row names of mtcars. And so if we want to figure out what's going on with that, let's go ahead and hop down to our console and just say row names mtcars. So our road names are all of the different car makes. And what's going to be a little confusing, at least at the start here, is that these car names are set to X, but they're not on the X-axis, they're on the Y-axis. So that sort of throws us off, and we'll see why in just a second. But at least for now, we can account for the fact that one of the axes is indeed the row names of that variable. Now, let's go ahead and look at this mgz variable and see what's going on with that. So if we scroll down here, go to our console, and post this, so we see that it is not defined. So my bad, I need to do mtcars. Open this up, and then we're going down here. So just for reference, what I did here, and this is a feature of GGPlot2. So we specified our data. GGPlot2 then knows that this is where the data is coming from. So when we call up this variable, mpg_z, this is sort of already known to be affiliated with this. But if I'm working down in console, after I run this, it's not going to know what mpg is because we're outside of ggplot2. So what I had to do was specify the name of the data set, the little $sign to say I want to access one of the columns, and then specify the actual name. So here we see a bunch of numbers, some negative, some positive. So it turns out that we are dealing with these right over here. so the miles per gallon, at least in terms of the values given here, the normalized miles per gallon given here. So figuring out what's going on here, the label, right? It turns out that that is actually corresponding to the labels on the little dots. And so we could sort of figure that out here where, you know, for example, we see 2.29 is corresponding to this value out here. 0.22 is corresponding to this one up here. So we can kind of go back and forth here, but we can sort of understand that, well, X and Y are the two variables from the data set, and then the labels on the data points, however we're going to visualize them in a second, those labels are going to come from this MPG Z value, which is the normalized miles per gallon. Great. So when we go down here, we're starting to see some really complicated things. We have our plus, so this is our base over here. But now we need to figure out what's going on with our geom function. So our aesthetic mappings, X, Y, label from the data set. Great. But when we try to figure out our geom function, we see that there's more than one, which is actually very common in ggplot2. So we have our first plus here. And so we're going to say, well, we have at least one layer. So we have this idea of the geom point, which if you recall from above is called as a scatter plot at this point. But ggplot2 doesn't sort of operate off of this idea of, you know, one's a scatter plot, one's not. It's just purely how the data is going to be represented. And so this first one with the geom point is saying that instead of, you know, a scatter plot, it's really just drawing black points on the space. And so we see that the size is 5, so that's how we got them to be bigger. We want them to be filled as black here. So they're sort of filled in with that dark color. And then we're specifying this argument here, the stat as identity. And so it's sort of allowing us to not be in terms of like a random scatter plot, you know, over time or something like that, but rather it's going to correspond to a particular value on the from the discrete value from the car names. So that's the points here. But then second, we have this other layer called geom segment, which turns out to be the segments that are connecting the line to this vertical here. And so how do I know they're all sort of built off of this vertical? Well, the first argument in the aesthetic within the second geom function is set to y equals 0. And so we're saying, well, where do I want to draw my line segments from? Well, it's going to start at y equals 0. The x-axis is going to be based off of our row names for our cars, right? So essentially the lines are going to be drawn vertically. And right now it's horizontally. I'll explain why in a second, but it will be drawn vertically as it corresponds with each car name. And then in terms of the start and stop, well, it's going to go from the y equals 0 axis to the actual point itself, the black point. It's the same thing with the xn. So, you know, where is it going to go in the opposite direction? Well, it's going to go up until the row names. In terms of the color of the line, it's going to be specified as black. So you can change that to whatever you want. But at this point, we should have dots and then lines that are sort of going off of the y equals 0 axis. Now, we have another layer. So we have geom text, right? And so the geom text is white and size equals 2. And so where do you think that's coming from? Well, it's the actual text from the label argument, right? That is going on these dots. And so we're saying, well, we have this text, so we've already accounted for how the x and y values are being represented in space, but we also need to figure out how to deal with this dimension. So the third dimension dealing with the actual values on the dots. And so the text is going to specify that we have those labels from this variable that are also aligned in Y, and then we need to sort of add a layer to represent that data. So that's all it is. Looks complicated, but not really when you get into it. But then we have a couple other things going on. So labs, which stands for labels, is going to allow us to add our title, so sort of the diverging lollipop chart, our subtitle saying, well, this is the normalized mileage from this particular data set, the empty cars. And then we have our y-axis being miles per gallon, and then our x-axis being the name of the car. So labs is an argument in ggplot that is the same exact thing as you would see in base R. So if you're just using the normal built-in R plot function, so if I did plot open, right, you would have labs is exactly the same. So, you know, you would do your X, Y plotting, you would say, 1, 1, and then we'd have, X lab. We're going to open that up and say something in there, Y lab, things along those lines. So it's the same sort of idea. The difference here is when you call labs, it's going to subset again. So instead of saying, main, which would be the title here or the subtitle in plot, you only have to write Y and X instead of, X lab, Y lab. Y-lim is the exact same thing as base R, so we're going to specify that we only want to go from -4 to 4. But then the thing that's sort of made this whole sort of demonstration a little trippy is that we take everything we just did, and then we're going to do what's called a coordinate flip. And so we're switching X and Y. And so this whole time when I've been saying these car names, right, they're supposed to be on the X-axis. Well, we're going to flip it to make it easier to see. So then it rotates up onto the y-axis. So X becomes Y and then Y becomes X. So if this explanation up here was a little confusing, totally understand it. But just know that this sort of works step by step. So we were sort of building up the logic, and then this little command at the end just flipped it. So it was easier to see these particular values. Now, this is something that I'm not going to explain right now, but we will get to in just a little bit. There are different themes in ggplot that allow us to get really professional looking plots. And so obviously there are some errors with this plot, so we would want to adjust the text to make it fit within the bubbles a little bit better. We would want to make sure these black dots aren't being cut off by the axes and things along those lines. But this is a black and white theme that, if done correctly, can look quite professional. So I'm not going to go through and write the geom function here, but I just want you to know that this is something that is relatively complicated, but just by understanding the three basic principles of data, which tells us where our data are coming from, the aesthetics, which tells us which variables we want to be working with from the data, and then the actual geometric mappings, which tells us how to sort of render those variables. We can pick apart what exactly is going on just by seeing a plot without even understanding really what the code's doing. So I've written up a couple of on your own exercises here. So I'm going to just show you what they look like real quick. But I want you to essentially go through and do the same thing where you're sort of identifying where the data is coming from, what the aesthetics are in terms of the variables, and then what sort of geometric mapping is it. So we see one here. We have another one here, which is going on. We're going to get something a little bit more unique relative to what we've seen. So we have another one here. And then finally, last one, relatively simple in terms of that, but we can see this here. So by doing this, it's good practice to figure out how to read ggplot, but it's also, a good way to, think about, what are the types of plots that I can actually accomplish with ggplot. So if I was doing this live, I would go ahead and take a 10-minute break and get some coffee, but it is not the time to do that right now. So I'm actually going to go ahead and continue. I'll pause the video here just so this doesn't get too large, but I will see you in just 1 second. Great. So we can now start working through the rest of our content down here. So as you can see, we do have quite a bit of things left to sort of go through. We'll try to be as brief as possible while still sort of delivering all the information that you need. Up first, I want to sort of take you through quite a few examples of ways that you can add additional dimensions to your plot by engaging with the aesthetic or AES function. After that, I'm going to teach you a little bit about faceting, just really short, showing you that it's there. Faceting, as we'll get to, is simply the ability to break up one plot with a whole bunch of data, and we can break those up into a bunch of subplots as they vary across a particular dimension. And then we're going to go through and move away from aesthetic, and we're just going to engage with the final, sometimes most important geom feature, and then kind of go from there and do some cleanup in terms of some important skills that we would expect to have. So some of the foundational arguments for aesthetic is essentially where we can add an additional sort of dimension here to highlight a particular feature in the data. So here, just going through our quick exercise, we have our data here, we have our geom here, and then our aesthetic, we have X being in the first position, Y being in the second position, and then we're going to see that we're going to mark something based off of the class. So let's go ahead and see what that looks like. And so it's exactly what we would expect. So it's the same scatter plot we saw before, but now the points are colored based off of the class of car. So two-seater, compact, mixed, midsize, and so forth. So this is just a good thing to know, that you can sort of break the two different variables and how they relate to each other. You can break that up into more sort of specific groups or clusters within the data. And it is relatively easy to do. Now, there is a little bit of a common mistake I want to flesh out when it comes to this idea of color. So for example, if I'm going to run this here, typically people will mix up this idea of aesthetic versus not calling aesthetic and just calling color. So these are the same data. So two different plots. I'm just going to make this a little bit bigger so you can see. Two different plots, it's the same data, right? But in this case, right, you have red dots and they're just called the color blue. Whereas in this one, we actually have blue dots and there's no legend. And so the difference here is that this one, the geom plot, and I'll comment this out just to demonstrate the point. This top one here is the one that's producing the red color by default, and just adding on sort of this legend over here where the points are referred to as the color blue. And so you don't want to add an additional aesthetic here when using color, because this is essentially just going to add the legend. So we'll see some examples of how to add a legend in a little bit, but it's important to know if you want to just change the color, you don't need the word aesthetic and then using the color argument, you can just do geom point and then just let the color be blue. Great. So real basic, these are one of those things that you just need to like see and then practice with a couple of times. So I encourage you to do so. We can also change it by shape though, as you would expect. So just as we can have multiple colors, we can have multiple shapes. And so this, of course, is something that you would only need to use in certain circumstances, because, for example, if the variable that you're trying to highlight, in other words, in a particular data set has something like 7, 8, 9 different features to it, it's going to be convoluted and confusing. But in this case, there's only 3 options. You have four-wheel drive, front-wheel drive, and rear-wheel drive. So we're just looking at that same scatter plot data, the displacement against the highway mileage for gas. And then we can tell, which cars tend to fall into which, which sort of category of cars here. So for four-wheel drive, front-wheel drive, rear-wheel drive relates to this idea of engine size against the mileage. So real helpful thing to know, just additional shape. You can also do size, which you've probably seen before. I haven't done any color here in this one. We'll see one later on where we can see color. But essentially, you can have the same scatter plot data, but then we can show like a trend of size differences. And so in this way, we can see more easily that in terms of the size of the engine, we're not going to have any cars that have an 8-cylinder engine, but have displacement of 2, for example, and really high mileage. So it's sort of a trade-off between the number of cylinders and the actual gas mileage that you can get. Great. So like I said, there's going to be some exercises on your own. There's a couple more features that you can add to this aesthetic function. But I just wanted to emphasize by showing you these examples that it's actually quite trivial. So it's still sort of the same fundamental grammar that we went over. So data, one aesthetic, geom, but we're just adding one extra argument, size, or we could say color or something along those lines, and then picking another variable to highlight your data in that particular way. And so it's a good way to sort of explore your data, understand potential relationships, but it's also just good for generating plots with multiple dimensions. The last thing I want to mention about these up here is that color can be written in GGPlot2 as color without the U and color with the U. So it doesn't matter whether you're using UK English or United States English, but they're both totally fine. So feel free to go through these on your own exercises when you get the chance, just to get some practice. But I do want to move into a quick sort of crash course on this idea of faceting. So I do want to quickly plug that there is a very long section in the textbook that's going to be in the course materials. It's specifically chapter 17, and I believe it's section 5. But you can sort of get really into the nitty-gritty of it. But faceting, I just want to introduce because it solves a problem we talked about earlier, where you want to show really complex data. There's all these different dimensions. There's a lot of things going on. But faceting allows us to break that up into smaller plots. And you'll see exactly what I mean in just a second. So this is the exact same data that we were just looking at. And so the difference here, though, is instead of sort of breaking it up by color for 2-seater, compact, midsize, etc., we've gone ahead and faceted it. And so you'll notice here that everything is on the same y-axis and everything is on the same x-axis. And the difference is we're just splitting it up based off of the car type. And so chapter 17 has some good discussion about why or when you would want to use this and when you wouldn't want to use this. But in this case, the data, showing it in color, while very cool, it's difficult for people to sort of figure out and group the different types on their own. And so, I might be able to say, oh, SUV is in this area, midsize is in this area, but what exactly is the trend for a subcompact, for example? So instead of taking up a lot of space with a figure like this and having people having to spend time to decipher it, we can just simplify it and just show them by breaking up into different plots here. So this is a good sort of habit to get into. I also, if I'm writing a report or something, I might show the global data and then sort of break it up into facets so people can see it. But this is just a good thing to sort of know. Now, there's a lot of things you can do with facet wrap. It's not literally just breaking it up. There's a lot of additional work you can do. So in this case, we're going to break it up across two variables. So both the number of cylinders and the drive. So drivetrain. So this is 4 cylinders, 4-wheel drive, 4 cylinders, front wheel drive. And then we see that there's no 4-cylinder rear wheel drive, at least in this data set. So you can sort of get a comparison of two different variables across each other. And then the labeler, we're saying that we want to label both. So we're demonstrating that both of these are here. So this is a good way to sort of think about, well, within each class of, cylinders or drivetrains, which ones are really driving a particular effect. And so we can see that there really aren't very many 8-cylinder cars that are front wheel drive. There's only one. We see that 5-cylinder cars in general are particularly rare, right? But we do see a lot of 8 cylinders for 4-wheel drive cars and things along those lines. So it's a good way to get a sense of general trends in which sort of variable combinations are driving a particular effect. Great. And so in this one, I just wanted to show you that you're able to sort of reorder the plot. So you're not sort of stuck with whatever GGPlot2 decides to go through, or what order it wants to put it in. So you are able to sort of go through and put it in a particular order. So it's something that I recommend, and I actually recommend going through. So in these exercises, there are some things that I want you to sort of answer, and if you need feedback or have trouble with any of them, let me know. But the biggest one that I really want you to do is to read the documentation for facet wrap. And so to do this, you just run this command. So the question mark ggplot2 : facet wrap. And what this allows you to do is sort of go through and see a bunch of examples, right? So how do we control the number of rows and columns with the command? How do we sort of change the panels in terms of where they appear and things along those lines? So this is actually the one that we just went through together. There's all sorts of different things that you can go through on here, but it also allows you to read about the different arguments. And so this is a good habit to sort of get into, to understand and learn about new features of things that you don't already know about. So every function that's well maintained has really good documentation, which appears under this help tab. But if you have questions, when you come into office hours, for example, about facet wrap, we can go through that. We can also, go through a little bit in the chapter as well, if that's helpful. But for most purposes, right, it doesn't really matter. The extra arguments don't really matter. People just tend to facet it off and have a particular, order in mind. So those are the two that I wanted to show. Great. So now we're going to sort of move forward again, and we're going to talk about our geoms, or our geometric sort of arguments that we're going to put on top. And as you've probably noticed throughout, right, aesthetic is sort of driving how what data points we're going to be putting in and how they're going to be broken up. But geom is actually telling us, how are we going to interact with the data visually? So like, is it going to be a scatter plot? Is it going to be a histogram? Is it going to be a bar plot? And so there's a whole bunch of them here that you probably recognize. So we have geom smooth, geom box plot, geom histogram, and then we also have a frequency plot over here. We have a geom bar, geom path, and geom line. So a lot of different options to go through, and we're going to show you some of them here. There's also additional ones outside of this, of course, but these are sort of the core plots that you'll probably be working with. Now, I want to emphasize here that we can do all of these plots I'm about to show you with almost no work involved. So just a couple of lines of code. And this is contrary to some really complicated plots that you've seen before. And there's a place for those complicated plots, and that's the goal. We want to get to that point. But with knowing really basic knowledge, you can generate really beautiful plots. So just know that by going through basic examples, you can really start to build up your experience relatively quickly. So let's look at the first one here. So we're going to look at geom smooth. So this fits sort of some form of a smoother to data. And then we're going to sort of display that with its standard error. And what do I mean by smooth, right? Well, it's basically this idea of instead of regression, right, we're trying to draw some sort of trend line curve or trend curve through our data, and we're trying to communicate our uncertainty. What's really exciting about ggplot is that it's compatible with all sorts of different ways to sort of draw a line through data. And so in this case, this is actually a low-S regression, which is considered one of the simplest forms of machine learning because it's sort of drawing a point at a local point in time. We can sort of quickly build this up. So low-S regressions only work for data points that are 1,000 or less. And so there are all sorts of alternatives to that also work with ggplot that I would encourage you to engage with in the textbook or online to quickly build up the complexity. But it's really exciting that you can sort of just do this through the typical ggplot argument. We have our input, our data set here. We have our X and Y in our aesthetic. We're declaring that it is going to be a scatter plot or we want to engage with points over time. And then all we're saying here is geom smooth. We want to draw a straight line through here. So there's two layers here. The first layer is just the actual scatter plot. And then what are we going to do? We're going to lay on top of it a smooth regression, the lowest regression, and we're going to have a confidence interval here as well. So, really exciting that you were able to do that. Now, as I mentioned earlier in the class, geom point does not necessitate a scatter plot. So it's not saying, so in this case, it is a scatter plot, but it's really saying that I want to show my points or my data points as little points on some geographical space or geometric space rather. So the way you need to think about this is you have to understand your data to know how it's going to be presented. And so in this case, because we have drive and highway mileage, well, we know that it's going to look something like this because we have a discrete variable with only 3 values. So four-wheel drive, front-wheel drive, rear wheel drive. And then we have our highway mileage. So you can see that they're sort of stacked up here. There are other ways to sort of present data like this that might be better than using geomplot. And so these are the classic jitter plots, the box plot, and the violin plot, which you've all probably seen before in research. So this is the exact same way to sort of show your data except by putting points that would be overlapped on a particular scale. You can sort of spread them out. So all of these here are corresponding to the four-wheel drive. All of these are corresponding here, and same thing here. There's sort of like a little box around it. You can do that. Now, reasons why you would like this is you can see all the data points, so you can actually see sort of the bulk of what's driving the particular effect. But we can also use box plots, which are helpful because you can see outliers more easily. You can see where the median is, so the central tendency, where you can't really see that on the other end. And you can sort of see the variance by showing these little quantile bars here. So trade-offs between these two, same way to show the data, but they highlight different features, as we talked about earlier. Now, another thing that I'm seeing more and more of are these violin plots. And this also gives you an idea of the spread. It doesn't quite declare outliers, though you can sort of guess, for example, because this closes off here and then there's some bulk up here, this is probably an outlier. But it does give you the overall sort of density of your data. And so if we go back to this, right, we see that most points in this first one are down in the bottom, and then it starts to thin out to the top. Well, we see that thickness reflected here. There's a little thinness, and then we have another sort of uptick in points. Same thing here, the bulk, you can see up here in the corner, the bulk is where we would expect it to be, and then it thins out in another direction. And then finally, this one on the right, so the rear wheel drive, it's pretty uniformly distributed, and we see that in the violin plot. So these are just really simple things you can just add right in right after our MPG and our aesthetic. But other than that, they are relatively easy to do. Now, if you want to add extra things to your violin plot, there are extra arguments, so you can always dress these up. But this is just sort of the foundational part of it. Great. Now, a core feature of any sort of data analysis is the histogram. It's important to sort of look at your data, understand the spread and things along those lines. So it's almost as easy as your base R, where you're sort of just saying hist and then putting in a data or a variable rather. But you can do it in just a couple extra words in GGPlot2, and then we are given all of the sort of functionality of the ggplot universe. So all we're doing here, again, data, aesthetic in this case, because it's a histogram, we're only having one argument, which is the X argument. And then we're going to go ahead and add our geom histogram argument here. So again, same thing where we close our parentheses, we have our plus sign, and then add it here. This is the histogram that we just created. So I was on the frequency plot for just a second. So we can see all of our different bins and things along those lines. But then the frequency plot is just sort of drawing a line where each point corresponds to the top middle of a bar. And we can sort of see the overall shape or outline of the histogram. Oftentimes you can sort of overlay this on top of the histogram. So that's a good option as well. But something to keep in mind, just like all histograms, we need to be able to change the bin width, because it changes drastically what you see. So here, for example, are two different bin widths. So this is a bin width of 2.5, so there's more data in a particular bin. And then this one, there's more data, or there's less data in a particular bin. And between these two, we're seeing that there's quite a bit of difference in terms of what features we're going to capture. And so if you're trying to get a good idea of your data, this minor shift would say, oh, there's only 3 clear peaks, whereas this data is far more variable, and the difference is only 1.5. And so all you need to do to go ahead and change that is just sort of go into the final function, which was the actual geom itself, And we just need to say, bin width equals 1, bin width equals 2.5, or something along those lines. Great. Now, so what if we wanted to sort of show combined and broken up plots? Well, we can use the facet function again. So say, for example, we have 3 of these different frequency plots where we, have our front wheel, fore wheel, and rear wheel, broken up by color. We want to show everything here. This is great, but then we might want to demonstrate the actual trend. So say we want to break them down into 3 additional histograms to get an idea of the overall shape. Well, it's actually relatively easy to do. So at the top here, this is exactly what we just did before, except with a bin width of 0.5. So nothing out of the ordinary here. Data are X and Y, or our X rather, in this case, because it's a frequency plot. We're breaking each of the different frequencies up by color. So there's 3 categories in Drive as we've been working through. So you can go ahead and expect 3 lines. We're then going to say that we want them as the frequency plot, and then we can plot it. But on the bottom, right, all we're going to do is exactly what we would expect. So it's going to be the data, our aesthetic, where we're saying this is our X value. We're going to fill the color of the histogram based off of the same class. So instead of color, where it's just drawing, a point, a certain color, or a line a certain color, we're going to fill the boxes of the histogram, or the bins of the histogram, by a particular color. We're then going to call up exactly what we'd expect, the histogram, geom histogram, where the 0.5 needs to correspond to the bin width up above. So we're showing a fair representation. And then we need to use the facet wrap down here, which we've seen before. And we're saying, oh, we're going to break it up by drive, where the little tilde here is saying by, or something along those lines. So saying facet by this variable. And then we're going to say, like, how many columns? Well, 1. So what we're going to do here is, or what we would expect to see here is just the 3 different histograms, as we would expect, broken up by color. And then we have our corresponding labels on top. Great. So here I just want to sort of reinforce that almost all of these different GMs can work with the same data. And so you basically have to decide what are the best ways to make your argument. And we've seen a little bit of that here. So when do you use a frequency plot versus a histogram? It really depends on what you're trying to do. But especially up here, when we were seeing the jitter plot versus violin plot versus box plot, there's different logic under them. It's the same data, but they highlight different features that you might want to communicate. So there isn't one that's always the best. So if anyone says, oh, I always love violin plots, or I always love box plots, they're definitely wrong. It's important to pick the data visualization as it's appropriate. And just to sort of demonstrate this idea, right, of showing data in 2 different ways, I want to show you a simple and a complicated example. So this is just a generic quote unquote drugs data set, right, where we have on the x-axis, generic drug A, generic drug B, generic drug C, and there's some sort of effect. So say, like, the positive decrease in, like, blood pressure or something along those lines. Well, there's 2 different ways to show this, right? So we have our bar plot, which we have not seen before, geom bar. So we're going to have exactly what we'd expect up here, right? But then we could also show the same thing as points. And so these show very different ideas, because for one, here, we're just only looking at the top value, and we're not sort of implicitly considering the area of the box to think about how big that effect actually might be. Whereas this one, the fact that it has area implies something to people. And so they sort of are able to sort of conceptualize the actual change across each condition. And so there's different ways to present these. This might also be easier to see versus the scatter plot, which is not easier to see. So definitely choices to make, but this is just a simple example. This actually does matter though in terms of getting results out of our paper. So here's just an example from the economics data set, which is inside of ggplot. And we're going to be plotting the date versus the rate of unemployment. Oh, wait. Yeah. So this is just the my bad. So I wanted to show this one down here is the one I want to show. So this is just a scatter plot here, or not a scatter plot, a time series plot. Same thing, date versus our rate of unemployment versus this is not a rate down here. So this is sort of just showing, you can have the same visualization, but by choices that you make in terms of your data, you can highlight a different proportion or a different feature. So instead of showing the actual rate, which we're looking at here on the y-axis, we can get a totally different trend by just looking at the net rate of unemployment percentage over time. So that's all I wanted to show with that one. But this is where I wanted to sort of go. So if you practice creativity in data manipulation, you could sort of see those hidden trends through powerful data visualization. And I think that this is sort of a great example of that. So we're still using the same economics data set as before, but we're going to highlight a different feature. So this is essentially a path plot. So what that looks like is we have a sort of a path through the data in terms of how they're connected. So it just draws a line, and then we're highlighting each of the different data points on here. So this looks particularly messy, and it's difficult to sort of track, right? And the reason why this would be helpful, right, is that this is through time. So if we could find the start somewhere, we could sort of, which is down here, we could sort of track through all of these different points and get an understanding of how the rate of unemployment has changed as a function of, or how net unemployment has changed by the rate of unemployment, or how they, you can do vice versa as well. But what is really helpful to note here is that we can sort of add another additional dimension, so year, just as we've done in the past up above. And we can sort of get this idea that unemployment rate and length of unemployment rate are generally highly correlated, but more recently in years, the length of unemployment has increased relative to the unemployment rate. And so we can sort of see that by this, corresponding to 2010 and above, there's a different trend here. And so it would be wrong to sort of treat this data, as one continuous thing. We would potentially want to break it up and do, analysis of the most recent data versus historical data, and try to figure out why that is. We might be able to highlight, features that are driving a particular effect or something along those lines. So, it doesn't mean, so when you pick a data visualization, even if it's the right one, it doesn't mean that it can't be improved to highlight features that you wouldn't necessarily have been made apparent to you. So this is just sort of a good thing to get in the habit of. Great. So now we're going to move on to just real basics of axes. So how do we change labels? How do we change scales? Well, we're going to generate some basic plots here. All of these are going to be the same data, but we're just going to change sort of some features, and I want to see if you can work backwards to figure them out. So in the first plot here, we just have city, highway, and a bunch of different points here. And so is that what we would expect to see? Yes. So there's no labels, there's no extra arguments. What this is doing here, this alpha, 1/3 is changing how the different points are colored here. So we don't need to necessarily worry about that for now. But there's no, in terms of the axes and the scales, there's no crazy business going on here. With the second one, it's exactly what we would expect. So we have the same plot from above, then we're going to add our plus, and then we're just going to do X lab, Y lab. And so the Y lab is going to allow us to change our Y label and our X label. So we wrote exactly what we want. So if we wanted to change, capitalization or something like that, that's where we're going to go in and do it. But while that's relatively simple to do, sometimes we don't want any axes or any labels. So we can go down here and say X lab null, Y lab null. If you had a main title, you could say main equals null. But by doing that, we are able to increase the size of our plot. We get rid of our Y and get rid of our X axis. And so sometimes that's helpful. So one, if you want to add your own axes in like LaTeX or something like that, you're welcome to. Sometimes if you're going to combine these or stitch this with other figures, you want to get rid of that. But it's just good to know, how do we add it? How do we take it away? Great. So moving down here, we have our classic jitter plot. So let's look at the first one here. We've seen a plot like this before, actually this exact same plot before. And notice the Y and the X axis are just our generic variable names that are fed into the plot because we didn't specify anything else. So drive and highway mileage. We're using our geom jitter, which we've already seen. And this is just saying, well, how far do we want our points to jitter? So width, you can change if you want the spread to be larger area for a particular discrete value. But 2.5 or 0.25 is just fine. Now, what we can do though is go ahead and change the x-axis and y-axis. So what's really cool about this, and it's nice that we sort of get this little warning message, is that we can directly specify what we want on the x-axis. So in this case, right, we're going to add our plus, and you're going to say xlim, we want F and R, which means that we're going to get rid of the four-wheel drive. So we're just going to have front and rear. This is not something that you can do in base R plotting, or at least easily. So it's important that you're able to do this in ggplot. So that's all it is. You just put them in quotes, you separate it with a comma. And ylim is more straightforward. It's just saying, well, what values do you want it to be between? So ylim is 20 and 30. So we have 20 up until 30. So you can rescale it in that way. Great. Now, what's important to know here is that that is only for discrete values. So this is another discrete case. It's the same plot. But if you're trying to do particular values down here, if you have continuous values, you can just specify the numbers. So you can just say from 10 to 50 or 1 to 3 or something like that to actually highlight your data. But one thing to know is that you can sort of get rid of NA. So with NA remove, you can get rid of values that cannot be plotted. So in some cases, you're going to have something turn an error. This is something that's built into base R, not in ggplot. So it's just something that is sort of helpful to know where, if you're getting an error where it says like NaN or NA is unable to be manipulated or something along those lines, you can use this to make sure that your plot is sort of going as expected. A word of caution about removing data this way. Usually missing data means something. And so, you have to, sort of the plight of a statistician is figuring out what do I do with missing data to still tell an accurate story. So just keep in mind that that's something that will make your code work, but is not necessarily something that you should always do or do in a particular way with your data. Great. So moving on into sort of a quick intro about themes. There are a whole bunch of different themes in GGPlot2, and then there's a whole bunch of additional themes outside of GGPlot2 to make your plots look very attractive. And why do themes matter? Well, this is how you sort of get your publication ready figures. So, if you get the geomes and the aesthetics and stuff like that accurate, then you can sort of dress it up by using one of these themes. So there are really basic ones like black and white and gray. So we're going to basically see all of these, but there's light themes and things along those lines. These are all fine, but it turns out that there's actually a library of themes, which I'll show you during our case studies, that allow you to use a pre-made high quality themes, which I've used in publications before. So you can see those in just a few minutes, but I do want to show you the basic ones where you don't have to install anything additional to do. Let's see if this one's going to pop up here. So it's giving me a little bit of trouble, so I'm just going to pop down, do it in console, just to save some time. Great. So here we go. So go back to start. This is our theme gray. So this is what I believe the default is in ggplot, but I could be wrong, so don't quote me on that. But all we're doing here is engaging with exactly what we would expect. So we have our random data. So this is just data at 0.1, 0.2, 0.3 for the y-axis 1, 2, 3. In terms of how we're doing this, so this is saved in a data frame, and then we're feeding that to geom, so our ggplot rather. So our data is still in the first position. Our aesthetic is just x and y from that data set, and then we're making it a scatter plot. So nothing complicated going on there. One thing that is important to know, and I guess I'll mention it here, I was going to mention it in a second, you can save these plots as variables. So while I'm sort of going through and loading something like this, this is, so the generic doesn't have the gray. So if I go ahead and plot this, right, it's nice to have this here, but I'm going to want to manipulate it in some way, or if I want to add to it later, you can save it directly in an object. So we can do that by saying base, or you can say P, which is typically the standard, or plot1 or something like that. But just like saving any other variable, we can print that variable. So you can say print. It's going to pop up in your plots. You can also in R not say print and just say the name of the variable. It'll pop right up like that. So that's just something to know. You can save it as a variable. But what that gets us is we can have a generic plot and then play around with it by adding things to it later. So we can say base, which is all of this plot up here, plus a particular theme, and then plus the GG title, so the thing that's going to go at the top. So if we wanted to do that, we can just do base plus the theme gray, and it's going to change it for us. So everything underlying is still the same. So our data points and how they're presented in sort of a scatter is still the same. But so, we can look at a couple of these different themes. So this is just a black and white theme. So the title is just up here in the top left. There's the line draw theme, which is essentially just the grid lines are changed so that they're like a softer gray. So that's just another possible theme that's helpful. You can have a light theme. So this is similar. Again, the grid and the lines are changing color here, but very minimal change. There's a dark theme where just the plot inside is turned into dark. So if you wanted to use light points on there, you're able to. And then we have the classic minimal theme, which gets rid of the box around the data and it just shows the grid lines here. So these are, just some basic ones in ggplot2. And as I mentioned, we can actually see some more attractive ones in a second. But it's helpful to know that, in terms of dressing up the aesthetic, you don't have to do all the work in adding the colors to the points or something along those lines. You can sort of just do the work of putting your data on, or into the aesthetic and onto certain geometric layers. And then you can sort of add an additional theme later or additional features to make it more attractive. Great. So the last sort of code that I want to show you here is, well, how do I save these? There's two easy ways to do it. So one, you can export it just like you can in Base R, where you click export, save the image. You need to change the directory. So I just changed, so you can go back and see this again, but you can click directory, pick wherever you want. So I'm just going to go to downloads, and then you can put a file name on it here. So test1, and you can go ahead and save it that way. And so that will be in your downloads folder now, but you can also save it right in your code, so you don't have to do it by hand. Well, this is going to be our plot. So this is just our little scatter plot here. Now we're going to save it as P, and then we're going to go ahead and print P. So our plot is now in the object P. But if we want to save it, we can use this command, which I'm not going to run, but we can use ggsave. So ggsave is nice because it works exactly what we'd expect it, or how we would expect it to work. So we have our name, so this is just plot.png, the object, which is P, so this is the variable that contains all the information about our plot, and then we're going to need to specify the width and the height in pixels. Actually, I think it's in, yeah, I'm going to have to look at the, it wouldn't be pixels, it would be probably, inches or centimeters or something along those lines. But so I'll have to like look at the default for there. But you're able to save the plot all the same directly in your command line. So we can go ahead and move over to our case study problems and some of the extra reading. But this is all of the sort of basics that I wanted to share with you about, what you can do with ggplot, how we can think about the actual code that we're writing, how do we read things that we don't fully understand to try to replicate it. But I think the theme I sort of carried through this whole lecture is that you can always sort of read a plot by looking at the three main core features. There's the data, so where is it coming from? The aesthetic, what variables am I interacting with, and how are they sort of being partitioned or faceted or something along those lines? And then how am I actually plotting them in space, which is the geom or the geometric layer. Great. So in a second, I'm going to move over to the PowerPoint, and we're going to talk a little bit about these case study problems and move from there. So thanks so much for watching, and I'll see you in just 1 second. Hi, everyone. So we're back here on the PowerPoint. I have two more short things for you today, specifically two different case studies that I'd really like you to try on your own. So if you are able to complete these case studies and then submit them to me, via email, I'll be able to sort of give you credit for this workshop. And so if that's helpful for your CV, or applications, if you're someone on the younger end of our audience, you're able to do so. Happy to sort of do that for you. So basically the case studies are for you to recreate the exact figure that I've shown here on this slide, and we'll show on another slide in just a second. So some hints here. You're using the economist data set, which is built into ggplot2. The X variable is just the date, whereas the Y variable is the unemployed variable, which we've seen before. Notice, though, that there's no Y-axis label here, and there's no X-axis label here. So those are some things that you're going to think about when you're adding your argument. in terms of your theme, you're going to be using something from 538, which is a very popular data science company. It's, at least in the United States, famous for its political polling and modeling. So this is a theme that's from their, or in the style of their figures, and that's in this library called GG Themes. And so I'll post these slides, but I've sort of given you the structure of the problem, or to solve the problem. So I'm going to install the packages you're going to need. So it's Doppler, which is a data wrangling, data sort of management package, which I'm actually going to do a workshop on in the near future. Library just loads that. Then we're going to install the package GG Themes, and then we're going to load that. This is going to say, well, we're going to deal with the economics data set. We're going to sort of do a little pipe here. And then we're going to do the exact code that we would expect to see. So ggplot from there. Now, the difference of doing it this way, as opposed to how we've been doing it, is just we've taken the first argument from ggplot and we've gotten rid of it. So instead of doing economics, comma, aesthetic, we're going to just do ggplot aesthetic this way. Now, what you need to do is everywhere there's a blank, so 1, 2, 3, 4, 5, 6 blanks, you need to fill in the information in the exact way that will give you this figure. So that's, obviously I've given you sort of the core here, so definitely go through and try to figure that out. A slightly harder case, I would not say this is difficult, but slightly harder, is to recreate this figure here. So it's more involved. It's going to be using the MT cars data set, which we've seen before. That's also in GGPlot2. Your X variable is miles per gallon. Your Y variable is sort of the quarter mile time, which is QSEC. So this is in the data set, so you can sort of see that relatively easily by doing structured data set and looking at your variables. And then the themes are going to be the same. So it's still the theme 538 from the GG Themes library. So you're going to be recreating this figure. Notice that there's 2 different legends here. There's an X label, there's a Y label. And I've gone ahead and done the same thing. So I've written out the structure for you. So there's going to be 1, 2, 3, 4, 5, 6, 7, 8, 9. There's 10 blanks in this one. And you're going to need to go ahead and figure out what needs to go in those blanks to produce the exact same figure. So I encourage you to try to figure that out to practice. And doing these sorts of exercises are a good way to sort of figure out how to read plots and, that you're excited about, and think about, well, what is that translated into code? But it's also, this is a good way to start to think about, well, how do I make my own plots from the bottom up? So I really appreciate everyone for coming to this workshop. Again, I appreciate you allowing me to do it asynchronously. Keep an eye out for me for an email from me about office hours, about posting the workshop materials on the website. And as I mentioned, you're welcome to join the Slack, so you can join our learning community there. So if you have any questions that pop up and I can't answer them, or I'm not available, you're welcome to sort of lean on your fellow peers on this journey to learn GGPlot2 and just generally data visualization. So thanks so much for watching, and hopefully I'll see you in a future workshop. Thanks so much.